Hey guys, sorry about that. We just fixed the YouTube stream link now, and we're just going to wait probably 1 or 2 more minutes for some people to come into the YouTube stream, and then we'll get started. Zach, can you post the link to the doc for people to have a bit of a browse while they're waiting?
Sure, yeah. We've put it in earlier, put it in again.
No, still not. Yeah. Is it?
Alrighty, sorry about that, everyone. Can everyone hear me okay?
Sounding good?
Sweet. All right, I apologize for the issues. I think we're all good now, and we're going to get started. So welcome everyone to the Smart Contract Developer Bootcamp Day 3. For those who are here, congratulations on making it to the 3rd and final day of the bootcamp. Now, yesterday we took the training wheels off and we got you guys familiar with creating, deploying and interacting with smart contracts using the Hardhat development environment. And you got some experience in using the Chainlink Hardhat starter kit as well. Now, today we're going to extend on what you learned on the Wednesday session, and you're going to learn some of the things that you can use to speed up your development experience, as well as discuss some of the important things to consider to ensure that your smart contracts have a high level of quality and are in as good a state as possible for when you put them on a production network. Once again, my name is Harry Papakrisiou, and I'm a developer advocate for Chainlink Labs. Today, I'm joined by Zach, also from the DevRel team, Melody as well, who'll be ducking in and out, and Colin from the community, who'll be helping us out as well. And today, we're going to work on refining your project and kind of doing things like local development and tests and things like that. And by the end of the bootcamp, you should leave here with a good understanding of smart contracts and blockchain, some experience in how to write smart contracts in Solidity, as well as some real practical experience in using Remix as well as Hardhat to create, deploy, and interact with your smart contracts. And on top of that, also, obviously, how to use Chainlink, tools and features, how to use price feeds, API, how to reach out to an API, how to use Chainlink VRF in your smart contracts, and really understand how easy it actually is to kind of get external data into your contracts, to get randomness into your contracts, and to use price feeds. So once again, it's the same kind of format that you guys are used to by now, 2 to 3 hour session. There'll be some presenting followed by some demos and exercises. If you have questions, ask at the end of each section. And if you're in the Zoom session and you need help during the exercises, definitely put your hand up. One of our instructors will help you out. Make sure you check your messages in Zoom if you have your hand up, because you'll be receiving a URL invitation. If we send you one and we don't get a response after a while, we may move on. So just please keep an eye on those direct messages. If you're on YouTube, ask questions in the chat. We'll be monitoring, I'll be monitoring. We'll try to help you out where we can as well. And at the end of the session, we're going to send a feedback form. Please make sure you fill it out this time if you want to get a proof of a certification document, sorry. We'll be collecting everyone's emails who completes this third day and who wants that sent to them. So here's the agenda for day 3, where we're going to just do a quick recap on the Hardhat starter kit and Hardhat in general. Then we're going to talk about working with local networks. Then we'll discuss smart contract security and testing. And then we'll finish off with like a little final exercise and talk about where can you go as a developer to learn more as you continue your smart contract developer journey. So first of all, just a quick recap on Hardhat. Once again, it's a JavaScript-based development environment for developing your EVM-based smart contracts. It's got a local Hardhat network. It's got a whole bunch of tools and features and plugins and things like that. And it's basically a very popular development environment at the moment in the kind of Solidity development community, as you saw in the Wednesday session. So, and once again, our Hardhat starter kit is a pre-packaged Hardhat repository that contains boilerplate contracts, code, tasks, config, tests, all of that stuff for basically using Chainlink in your smart contracts. And you guys did some deploying and interacting with it in the last session. So let's talk about working with a local network. So Hardhat comes with this thing that's called the Hardhat network. And it's a local Ethereum network that kind of runs on your computer. It's a node, and it allows you to run and test your code, and you can run it in a standalone fashion. You can connect it to things like MetaMask and things like that as well. And there's just some info on how it runs. I won't bother going through all of it, but the main thing to note is it runs locally. It's fast. You don't have to wait, 15 plus seconds for blocks to be mined and things like that. And one really cool feature is that you can fork the mainnet. So fork the mainnet, what does that mean? So traditionally, when you run a local Hardhat node or any like kind of local node, really, you start off with a blank slate. The blockchain has no blocks. You're given, 10 or 20 accounts, and they each have a whole bunch of ETH, and you can do whatever you want. But let's say you don't want a blank blockchain when you kind of do local deployments. Let's say you're building a smart contract that connects to an Aave lending pool contract or something. And kind of, if you want to test that locally, then you have to deploy all the Aave contracts and, set them up in a certain state and things like that. So you can actually take a copy of the current Ethereum mainnet and use that as a starting point for your local network, so that then you can have all the smart contracts, all the accounts and everything set up exactly as they are in mainnet when you take that snapshot. So yeah, really useful. So we're actually going to go straight into a demo and an exercise. So I think Zach sent the exercises, or Colin, but if you guys just want to watch me do it first, so you can kind of get a good idea, and then we can kind of move on, and you guys can have a bit of a play. So the first thing you'll need to do is you guys should, we're going to start off using the Hardhat starter kit that we were playing with in the last sessions. So definitely have that open in VS Code as your starting point. And what we're going to do is we're going to make sure our default network here is set to Hardhat instead of Kovan. So in the last session, we were working exclusively on the Kovan public testnet. This time we're going to work on the local Hardhat network. And apart from that, you want to, what else do we need to do? I think for the first one, that is it. So to start your local Hardhat node, as you guys can see, I've got my terminal here. Hopefully that's big enough. You actually need to, you need to open a new terminal in this case, because we're going to be running commands in one terminal and we're going to be running the node in another. So this little plus button here, click it. If you have Windows, make sure you're running command prompt, CMD. So you click that, and as you can see, we get a new terminal open here, and you can actually switch between the two by clicking on each of them here. So I'm going to go to the second one here. I'm going to run npx hardhat node, and hopefully that will start up my local node. Cool, that's all good. So the next step is we now are going to go back to our other terminal that we had open here, and we're going to run a deploy script to deploy our smart contracts to the local Hardhat node. And there we go, we get a whole bunch of output there, like you guys saw last time. And as you can see, I can, whoops, that's not right. As you can see, I can copy the tasks that were outputted, and we kind of get a result. As you can see, the result is not the correct result, and that's because we use what are called mocks. So I'll just quickly show you those as well. So in the contracts folder, we have a bunch of mock smart contracts, which are kind of used to simulate, in this case, interacting with the Chainlink, Oracle Network or Chainlink contracts. So like you guys saw with the API exercises, there's an Oracle contract that sits between a node and your smart contract. We kind of mock requests going into and out of that. So we kind of simulate connecting to an actual Chainlink network, because when you run a local blockchain, you can't connect to a Chainlink Oracle network because Chainlink does not know about your local blockchain. So we've got some mocks here. We'll go through mocks a bit later in the session actually. But for now, yeah, you guys can just deploy the Hardhat node, start the Hardhat node, sorry, deploy your smart contracts, interact with them. And once you've done that locally, what we're going to now do is we're going to stop our Hardhat node, and we're going to actually fork the mainnet. So in your hardhat.config, you need to remove the comments in this forking section like this. And the exact syntax is in the exercises, so you should be able to see. So basically saying, hey, we want to start a Hardhat node, and when we start it, we want to fork the mainnet. So it uses the mainnet RPC URL. So in the setup instructions, you should have signed up to Alchemy, I believe, and gotten a URL key from there. You need to put that into your .env file as per the setup instructions and the exercise 3 instructions. So it will use that URL to fork the mainnet. The only other things we need to do, I believe, is we need to modify the deploy script for the price consumer contract. So what we're going to do is we're going to fork the mainnet, and then we're going to connect to a mainnet price feed smart contract. So in this case, I've created another config in the Hardhat helper config file here for the Hardhat network, which is 31337, sorry. And I've basically connected to the mainnet ETH USD price feed contract. So if I go to the Chainlink docs, which is here, this is no, that's not mainnet. This is mainnet here. So the mainnet ETH USD is that one there. Yep. So we're saying we want to connect to the mainnet ETH USD price feed here, and in our deploy script for the price feed contract, we're saying we're going to comment out this if statement here, because we want to always grab the config for the ETH USD price feed address from the config file in this case. So we want to grab this value here and use it so that when we deploy our price consumer contract, it sets the aggregate address to the mainnet ETH USD price feed. So I think that's it. The next step is we need to start our node again now. So we go npx hardhat node. So this will start it as a forked version of the mainnet now. So no, we're not going to have a blank slate blockchain anymore. It might take a little bit longer than usual. cool. So that's done. So now what we can actually do is we can actually run the block number task that we have in the tasks here in the Hardhat starter kit. So this will just get the current block number in the blockchain. So if you run it on a local network, usually it will return, 0 or 1 or whatever. But in this case, you see we get the block number of 128.38712. If I go to Etherscan and I have a look, yeah, it's pretty close. So we're running on a forked version of the mainnet now. So what I'm going to do next is, so that we can see that we're on a forked version of the mainnet, I'm going to deploy the smart contracts in the Hardhat starter kit again to our locally running Hardhat node, which is a fork of the Ethereum mainnet. We'll give that a minute to complete. And then what I'm going to do is I'm going to run the read price feed task on our deployed price consumer contract. And as you can see, we get a return price of $1,910. If I go to the Chainlink ETHUSD price feed page at data.chain.link, you can kind of see the result there. So it's the same thing. So we started a local Hardhat network, which is a fork of the mainnet. We deployed smart contracts to that. And for the price feed consumer contract, we pointed it to the mainnet ETHUSD price feed contract address. And then we could actually get that exact value at that point in time when we took that snapshot. So I think that's the end of the first exercise. So we'll let you guys have a bit of a play around. Let us know if you have any questions and we'll try to help you out. But yeah, the aim of this exercise is to start up a local node, do some deployments, fork the mainnet and do some deployments and see how you can kind of connect and interact with mainnet smart contracts on your forked kind of blockchain. Thanks, guys. Any questions? Feel free to ask.
Harry, quick question.
Sure.
When you fork the mainnet, are we talking about the Ethereum mainnet? Is that the complete blockchain that we're making a snapshot, or just a section of that?
I believe that it is the complete blockchain, but I know that it's like, hundreds of gigabytes. So I don't exactly understand the completeness of the snapshot, but if you need to interact with any smart contract on the Ethereum mainnet, you can grab that address and you can do all the interactions and stuff with it. So it's kind of like as if you were working on the mainnet, but you're not really. But also it's static, so it's basically just a snapshot in time. It might just kind of take your alchemy key, look up the information and kind of do something with it. So I don't think it actually copies hundreds of gigabytes.
And it's ideal for us, for developers, right? Because it's a lot faster.
Yeah, so local development is obviously faster because you don't have blocks waiting to be mined, and you don't have to, go to faucets and get ETH and stuff like that. But local development is also a bit tricky because, like I said, you usually start off with a blank slate. There's no blocks, there's no contracts, there's no nothing. So if you need to interact with other contracts and stuff, like the price feeds, that we saw, it's a bit hard. You need to deploy other stuff too. Whereas if you just fork the mainnet, all that stuff is there so that you can kind of test your interactivity with other contracts and stuff, so that, when you go to mainnet, you've already kind of tested that kind of connectivity and those integration tests.
Right. Awesome. Thank you.
No worries.
So, can you say that like a normal workflow would be to deploy first on a local forknet, and then deploy on Coven, and then deploy on mainnet?
Yeah, definitely. You'd probably be starting off local first. So whether it's just pure local because you're just doing your own smart contracts that don't interact with anything else, or if it's kind of local with a forked mainnet, that's definitely the way to start, because like I said, everything's quick. You're not waiting for blocks to be mined. You don't have to kind of, get testnet ETH and things like that. But then you get to a stage where, you do want to get it tested and working on a proper public network such as Coven or Rinkeby or something. And then, mainnet obviously after that.
Right, thank you. One other question is, how does the deploy know that it should deploy on a local network? Is it because we have like the Ganesh property on the Hardhat config? You are on mute if you're talking.
Yep, sorry about that. Yeah, so in the main Hardhat config file here, we have the default network set to Hardhat. So any commands that you run on the command line, you can always specify a network. So we can say deploy network Coven. And even though we have a default set to Hardhat, it would do it on Coven. But if you don't specify a network, it will always go to what the default one is.
Yeah.
Does that make sense?
Yeah, of course. Thank you.
Sweet.
Hey, Ari. You stated this week that when we open a new command line, we need to switch it from PowerShell to command prompt, correct?
I found less issues when I did that. Yeah.
Okay.
You can try with PowerShell, but I found that, there were some issues with certain commands. And I found that when I was testing these exercises on my Windows laptop, the command prompt was, playing a little bit nicer.
All right, thank you very much.
Sure. In general, with smart contract development and kind of working with, NPM and packages and things like that, Windows is a bit more finicky than if you're using Mac or Linux. I switched to Mac a few months ago and never looked back really, because I just had so many issues with Windows.
Awesome.
But you can do it with Windows, but sometimes it's a bit more finicky.
Can you just share a little bit about your workflow for managing multiple environments so you're not constantly like hard coding the config file and flipping around between, which network you're deploying to?
Sorry, I couldn't hear that properly. Did you say what's my workflow for dealing with multiple environments?
Yep, exactly.
Yep. I'm kind of a bit, I guess you can go either way, but I tend to be more of a set a default network and then like never pass in the network flag type of guy, because like I type it in, I save it, and I know in my head, yep, this is what I'm working with now. Rather than like have a default network and then like put a flag in of another network and stuff. Sometimes I'll get jumbled up. So I tend to be like, yep, this is what I'm dealing with now. And then if I want to go from one to the other, I just change the default network, and that way, I kind of know where I'm at. And another advantage of that too is that the up button on the terminal here, which gives all of your history. Like if you're doing stuff lots of times, like I'll just go, up and enter npx hardhat deploy, and I know that my default network is set to what it needs to be. But each to their own. Some people might like to do it the other way.
Is it a very common practice to have multiple env files for the different environments? I guess I'm trying to just understand like a little bit more on like maybe how continuous integration and deployment would kind of like work into this workflow.
Yeah, we want to actually talk a bit about CI, but there's so much to cram in 9 hours. But that could possibly be a good topic for a future bootcamp session, actually.
Okay, cool. Thanks.
Sorry, just another thing, guys. If you get an error, take a look at the appendix. We've put a couple of common errors in there when you're trying to start the Hardhat node, and there are a few things that you can try to kind of get that resolved. So check that out, and hopefully that will help you. If not, if you're in the Zoom session, put your hand up. And if you're in the Chainlink YouTube, post the error and I'll take a look.
But a Google Doc may have the env variable name for Alchemy mainnet RPC URL. I guess incorrect, or the instructions. Whenever I run npx hardhat deploy, then it's looking for mainnet RPC URL as the variable name. So
Which section of the doc is that? Sorry.
number 4 there, where you're adding the Alchemy mainnet RPC URL. I think when you run the deploy command, it's actually just looking for mainnet RPC URL. Is what?
Yep. Let me just double check that. Yeah, you're right. Cool. Thanks for that tip. I'll update the doc.
Harry, quick question on the first exercise.
Sure.
I'm not having an error, but I don't quite understand the purpose. Initially, what we say is we want the default network to be Hardhat, but Hardhat is all commented out. Why would we say Hardhat as a default network?
Where is Hardhat commented out? Sorry.
Well, the default network, we put Hardhat, but then when we go down in the configuration, the Hardhat is commented. I'm on step 5 of the first exercise, and we comment private key for Coven. And I understand that we are working with Coven locally, well, actually not on Coven, on locally. So I don't understand that step really.
So
Hey,
that
Lewis,
step.
I think that's just a typo. It's just a typo in the document.
So it
Step
should
5.
be localhost instead of Hardhat, the default network.
No, it should be Hardhat as per how mine is here on the screen share. So the only thing that's commented out in that at that stage is the mainnet forking, which is this part here, because at this stage we're not forking the mainnet yet. We're just saying we want to use the Hardhat network and we want it to be like a blank slate, a fresh, new blockchain.
Oh, okay. We just need to make sure that that is commented out there. Okay.
The forking stuff, yeah, because we don't want to fork. You're not forking the mainnet for that part of the exercise. That's the next step.
So if we have Hardhat as the default network, but Hardhat is all commented out, it will go to localhost?
I don't actually know what will happen if you have Hardhat commented out and you have Hardhat. It'll probably throw an error. You can feel free to try it.
I did, and it worked. It did it
Oh,
locally, but I don't know. I guess it just picks up localhost.
Yeah, so when you start the node, it kind of, the way in which we do it, it kind of broadcasts it as kind of the local host. So there you go.
Got it. Thank you.
So every time I want to run a task, do I have to deploy?
Every time you wish to run a test, if it depends on if you change your smart contracts or not. So if the smart contracts haven't been updated, then you don't have to redeploy them. You can just create and run scripts or tests at will.
Okay, so if I just change the code and run the task, it will use the new code?
If by code you mean task or script code, then yeah, you can just change it, update it, and then rerun it, as many times as you want. But as soon as your smart contract changes, that's when you need to do another deployment.
Okay, makes sense. So even if I'm defining new tasks, that's true?
If you're defining new tasks, as long as you add them to the Hardhat config file here, so here are where all the tasks are kind of added, then yeah, you should be able to create a task after you've done a deployment, and then as long as you add it in here, you should be able to still execute that task.
Okay. Thank you.
Harry, quick question.
Sure.
about the request data line on the API consumer contract.
Sure. Yeah.
So do I use my API consumer v3 contract for that line?
So you're talking about the request data task, is that right?
Yeah, correct.
And your question is around how to run it or what to pass into it?
Yeah, like my question is, what contract address do I use? Do I use like the Trace consumer v3 that we just deployed?
No. So when you deploy your contracts, you'll see each contract has its own kind of section. So if you look at my screen here,
yeah,
the API consumer one was deployed to this address here. And it's this address here that you need to call the request data task with. So we're saying, call the request data task for this deployed contract here.
Okay. Yeah, I'm trying that line. I get like, what do I get? Okay, it works. Must have been like a typo in my line. Great, thanks.
No worries.
Hi there. Could I ask you a question about the forking?
Sure.
I had in my mind that as soon as you start npx node, you're pretty much working on a fork of the main chain. But whenever I run Hardhat block number, the block number increases. So it still seems to be keeping track of the mainnet blocks. Is that right?
Yeah, because it's through the Alchemy RPC URL.
Yeah.
Then yeah, each time it hits it, it will get whatever is at the Alchemy RPC URL. But you can. There is a command where you could specify a specific block as well. I don't think it's in the exercise, but if you go to the Hardhat website, well, that's too big. If you go to the Hardhat network, you see all the flags and kind of configs that you can kind of play around with, and where you can pass in block numbers and stuff as well.
Okay, so by default, it just follows the head.
It just follows the
So here's a question I had. If we are deploying, I suspect we are deploying within the block on the fork that we have locally.
Yeah.
Yeah. So what's going on here? I'm trying to find the head of the chain, because if I'm deploying a local block, the mainnet doesn't know about this block. Does that mean that?
Correct.
They're two different.
It's your own. It's your own blockchain. It's not. It's a copy of the mainnet, but it's not the mainnet. So you're right. They don't know about your block or your transactions.
So they don't know, but I do. So in a sense, I can still call or refer to transactions on the mainnet thanks to Alchemy, while at the same time interacting with my own contracts, which are on a block locally. So
yes, that's exactly right. 100%.
So I have knowledge. As opposed to regular nodes on the mainnet, or actually any net whatsoever. With this tool, I've got the ability to track two different heads, two different chains, my local one as well as the Alchemy one, the main one.
I don't know if it's two different chains. I think it's more of I guess it's kind of like a combination, I guess, where you can add stuff to the chain, but then what it gets from Alchemy gets put on there as well.
So the last one about this, do you think that the block that I got to deploy my contracts onto is added always by Alchemy or by Hardhat to the head of the mainnet?
I don't know the inner workings of exactly how it works, but I'd imagine that it would get the Alchemy block or the latest block, and then it would also recognize that you're trying to do a deployment, and perhaps it would put yours in another block before the Alchemy one or after, I'm not sure. But the end result is you've got everything from Alchemy mainnet, and you've got your local Hardhat deployment transactions included as well.
Yeah, I guess the reason I mentioned this is because imagine two developers and I have a CI/CD, and as part of my test, I want to test against data that's being put onto the mainnet by another developer, or say on the actual mainnet itself. Say I'm trying to track data on the mainnet. Does my contract have access to the latest data on the mainnet pretty much live thanks to Alchemy? So whenever I run my integration tests locally, I'm always up to date with the latest head and the latest nodes from mainnet.
Yeah, I think there's a slight delay, but I don't think it's that long. But in theory, the answer is yes, because it goes to mainnet and you kind of get access to mainnet. But like if you do a local deployment as a fork of mainnet and then straight away get the block number, I think you'll see it's already like 2 or 3 blocks behind or something. I'm not sure.
Yeah, so it gives tracks there with a small delay, but that's it. Yeah. Cool. All right. Thank you.
No worries. We'll give it just 5 more minutes, guys, and then we'll have to move on. But there'll be another exercise very soon. So if you haven't finished, you'll definitely get a chance to catch up.
Hey, Harry, I have an off-topic question. For the price pairs on the various networks, you guys have them deployed on specific proxy addresses. Would there ever be an instance where these contracts need to change?
You mean the underlying contracts?
Yeah, so like, the first one for 1 inch in ETH is on, 0x72. Let's say you guys needed to make a change. Is there any way that you would be able to make a change without changing the address? Because I'm sure that there's some apps that rely on this specific address.
Yeah, that's kind of why we use the proxy contracts, so that if we do need to upgrade them, we can do so without kind of having to tell everyone, hey guys, that was the old one, this is the new one.
So it's like a design pattern.
Yeah, correct. So it's proxy. It's a design pattern where you kind of say, this is the thing that everyone connects to, and then that points to something basically. And that's currently what's being used for most, if not all of the contracts, I think.
Yeah.
Zach, correct me if I'm wrong.
Thanks, Harry.
No worries.
Harry, so I have a related question. If you have a proxy contract, how do you secure it so that only authorized people can update it?
You need to be very careful about who has access to call what functions in the aggregator, in the proxy contract is probably the best answer I can give. Yeah, you want to make sure that the visibility and the accessibility of the functions to upgrade what it's pointing to can only be called by specific actors, I guess.
Okay, thanks.
Because it wouldn't be good if anyone can just kind of connect and change the underlying aggregator contract.
Will we be covering something similar in today's workshop?
We will be going over smart contract security at a high level, yes, and running tests, yes. In terms of pure smart contract security considerations, I would love to have included lots more of it, but unfortunately in a 9-hour course, there's only so much you can include. But I'll actually be talking about that exact subject at SmartCon developer track this year. So if you haven't got a ticket, definitely check out SmartCon. We've got a developer track where we've got a whole bunch of developer focused talks. And yeah, I'll be speaking specifically about smart contract security and some of the types of attacks and exploits that occur.
Okay, thank you, sir.
I have one question related to the link token. I understand that for Ethereum, you need the token for, like, not the token, you need the stuff to be able to transactions and have a limit on the transactions. But why do you need link tokens for executing the link contracts?
Sorry, I didn't understand that question. Can you repeat it?
So I understand that we use Ethereum and the gas fees to limit the transactions, but why do we need the link token to execute the smart contracts from Chainlink?
A link token is a payment to the node operators in the form of gas, if you will, because the node operators, not only do they need to do some kind of API call or external computation or random number request for you, but then they also need to post that result back on chain, and they need ETH to do that. So it's basically paying them to do the request and also to subsidize them having to spend ETH to then give you a result back.
Okay, great. Thank you.
No worries. All right, guys, let's move on now. Most of you look like you've finished. Pause sound. Cool, that's a perfect segue to start talking about smart contract security now. Now, like we just discussed, you really have to be paranoid when you're kind of building smart contracts, because nothing's hidden in the world of permissionless blockchains. Everything's visible. You can see what contracts have what value in them. You can see you can get the code and all of that kind of stuff. So I think this is a really good quote. Now, some of you developers might already know a couple of these things, but for those who may not be as experienced, I'm just going to go over a couple simple concepts. So when talking about smart contract development, there's two main sources of security problems or considerations, and that's bugs in the blockchain infrastructure or bugs or vulnerabilities in the smart contract code itself. So generally, the EVM and Solidity has matured over the years, and a lot of mistakes and issues have been fixed. So the majority of issues that are found these days are specific to smart contract code, but not all. So previously in session 1, we discussed smart contract exploits due to using insufficient market coverage in your oracles, or using centralized oracles, or using centralized oracles for randomness. But now we're going to talk about on-chain security of smart contracts themselves. And in terms of the life cycle, smart contracts could be thought of as kind of like hardware rather than software. So in software, if there's an issue with software, you can release a patch, or you can easily fix it and send it out as an update, and people can kind of get an update easily that way. But with smart contracts, it's not usually, you can't do that with a smart contract unless you program it into the smart contract itself for it to be upgradable. And that's a topic for a whole nother thing. So you have to think of it more like hardware, where once it's out into the world, it's out, you can't change it. And if there's an issue, they generally have to, depending on what it is, they might send it back and they'll get a new one, or they might get it fixed or something. But in the smart contract world, it's out there, and if there's an issue with it, that you generally have to deploy another version and say, hey guys, please use this new one instead of the old one. So there's a bunch of well-known smart contract attacks and exploits that I've listed there. And once again, I wish I had time to go through them all in detail, but I don't. But if you're going to be attending SmartCon, I'll be giving an in-depth explanation on these. So highly recommend checking that out. So how can you minimize the chance of anything bad happening in your smart contracts? One of the best things is testing. So testing is one of the greatest methods of trying to increase the overall security of your smart contracts. So once again, if you're a developer, you know all of this stuff already. So testing in the context of a smart contract is just trying to execute every line, or as many lines as possible in the smart contract, and kind of work out what are the bugs, what are the potential issues with it. Because when you're combining immutable programs that hold and control movement of funds, doing stuff like testing becomes very important, obviously. So a general rule of thumb is we should try test as much of a contract as you can in terms of the lines, and focus on the most important scenarios first. And they're great for catching careless mistakes and edge cases as well. So the difference between a bug and a vulnerability. So a bug is when you've got an issue that leads to a planned scenario not happening as expected. And a vulnerability is when something completely unexpected happens, right? So testing generally won't prevent a vulnerability because, it's not something you would have expected to happen. So two types of tests. Once again, if you're a developer, you know this. Unit tests focus on specific single behaviors or components within your code. And integration tests are more complex tests that validate interactions between other things. So in this context, interactions between other contracts, or with things like a decentralized Oracle network and things like that. So the general testing pattern taken in smart contract development testing is the arrange, act, assert pattern. So we're arranging the initial conditions required. What do we need to set in our test before we execute it? Then act, we call the function that's going to be tested, and then assert the results. Say, this is what we expect to happen. Did it happen or not? So a couple things to note about writing good unit tests. A good unit test should be simple. So each test should be evaluating just a single behavior. And when it fails, you should know exactly why it failed, because it's just focusing on this one specific thing. Should be repeatable. You should be able to run the unit tests multiple times and always get the same result, as long as the code being tested has not changed. It should be isolated. So tests should not depend upon other tests, and you should be able to run the tests in any order, together or independently, and you should always get the same outcome. Tests should be very readable. So you should put long descriptive words and comments, because generally with tests, once they're deployed and executed, chances are if it passes, you're not going to look at it again for a long time until something breaks. And then when it breaks, it might be someone else that's looking at it, and you want them to know kind of what's going on. And finally, they should be fast. So they should be written with speed in mind, because every time you add or change bits of code, you're going to be running tests to confirm that everything's still working properly. So yeah, that was unit tests. And integration tests, very useful and required when dealing with things such as Chainlink, a decentralized Oracle network, because you're interacting with things off chain. So that's definitely an important aspect there. And for example, if you've got a front end in your smart contract or decentralized application as well, you can actually run JavaScript tests, which actually test how things look outside the blockchain and see if the front end will be able to successfully interact with your smart contracts. Just a quick note on some of the tools for testing. I think we're going to use a couple of them today here. So Waffle is a really good library for writing and testing smart contracts, and Mocha and Chai, some of you might know them. They're very popular testing framework and assertion libraries for Node.js. So there's this really cool tool called Solidity Coverage for smart contract development. And what this tool does is it looks at all of your tests and it actually produces a report that tells you how much of your code is being tested, how many of the statements, how many of the branches of each statements, what lines weren't tested, what lines were tested. So it gives you a good report. So you can kind of go, oh yeah, I've tested most of this contract, but this one I'm only testing 20% of it. And you can kind of go and look at the tests and, you know, try and add some if you need. So the concept of mocks is basically, like I explained earlier, when you're working on local development environment, you don't basically have connectivity to external things which you normally would on a public network, such as if you want to use Chainlink for anything, Chainlink does not know about your local blockchain running on your computer. So what you can do is you can deploy smart contracts that pretend or basically mock up interaction with kind of the outside world and things that are external to the blockchain. So in the case of Chainlink, you can deploy aggregator contracts and VRF coordinator mock contracts that make your smart contracts think that it's interacting with Chainlink, but actually it's not. It's interacting with these kind of mock contracts. Cool, let's go to our next demo. So this exercise, I think we're just going to run the tests. So what I'm going to do is I'll show you them first. So in the test folder, we've got a split of integration and unit tests. And as you can see, the tests are kind of set up in a way where we set up the conditions and then we kind of basically assert the expected result. So for the price feed, all we're doing is we're checking that the price feed value that we get is a positive number. So that's just a simple unit test there. And in the case of the random number consumer and the API consumer, we're just testing that we get I think a transaction ID when we do a request. There you go. And in the integration test, they're specifically for the API consumer and the random number consumer contract. That's where we actually test that we actually get a result back as well. So for VRF, we test that we make a successful VRF request. And then in the test, we're actually waiting 30 seconds for the Oracle to receive the request and then process it and send a response. And then we're actually kind of checking to see that we get an actual response that's greater than 0. So yeah, the tests are split into integration and unit. For the unit tests, I think we're going to be running them on the local Hardhat network. So I'm just going to make sure that's all still set properly, and I think it is. So let me just copy this. So I think we're going to use Yarn for the test. So Yarn's another, oops, here we go. Yarn's another popular package manager. And we've actually set it up so that when you run Yarn test, it basically runs all of these scripts that we've kind of specified here. So you don't have to kind of do it yourself. So if I just clear, go Yarn test, it's going to execute all of the testing scripts there. So as you can see, our first test passed. Oh, it's going too fast. Oh, I got an error with this one. I'm not sure why. I'll have to have a look at that. But as you can see, you're either going to get a red or a green, which says if it passed or not. And what we'll do for the next one is we will change our Hardhat network to be that's not the right file. We're going to change to the Coven network, because for the integration test, you need to do it on a public network, obviously. And we're going to run npx hardhat deploy to deploy our contracts to Coven again. So we'll just give that a minute to complete. You can leave your Hardhat node running, by the way, while you're doing stuff on Kovan. As you can see, I haven't stopped it or anything. Cool, that's done. And now I'm going to run yarn test integration, which will go into, it will basically execute all of the integration test scripts here that are specified. So that's kind of the general approach that taken for writing tests with smart contracts in Hardhat. You create the tests in a test folder, and then you can manually run each one using npx hardhat test, or you can set up scripts like this in package.json where you kind of can just run them all in one go, which we've done in this case. So we'll just give that a minute to complete. The integration tests are a bit slower, once again, because we are waiting for those callbacks from the oracles. While that's going, I'll just explain the last thing that we're going to do now is you're going to be adding the Solidity coverage library to your Hardhat config, and you're going to be installing it as well. I think I've already installed mine, so I won't do it again. And once that's done, we'll just wait for this to finish. We're going to run a coverage report as well. So I think in this case, we're going to run the coverage report on the unit tests. So once this finishes, I'm going to change my default network. Cool. So there we go. So all 3 integration tests were successful. And I will now change my default network to Hardhat again. And what I'm going to do, I'm just going to deploy them again, just in case, although I don't think I have to. Cool. So now I'm going to run npx hardhat coverage on all of my unit tests. So as you can see, that first one failed still from before, so I'll need to look at why that was. But as you can see, we have a report here, and it specifies what percentage of statements of each contract executed, what percentage of branch of the statements, like if it's an if statement and things like that, on all the possible scenarios, what percentage of functions overall, what percentage of lines overall, and which lines were not tested are listed in that report. So you can kind of use that as a guide to go and try and improve the overall testing coverage of your tests. So that's it, guys. I'll put it over to you now. Have a bit of a play and reach out if you have any questions. But yeah, the whole aim of this is to just get familiar with executing tests, unit tests, and integration tests.
Yeah, just a little shout out. If you fill out the feedback form today, you'll get a little certificate of attendance. So we're kind of shouting that out on all our channels. All your feedback is appreciated, and we're going to use it to improve these events. So looking forward to see what you guys have to say.
Can we also share the slides with people somehow?
Yeah, sorry about that. The slides will be going out with in PDF form. So we're going to send out the slides, the exercises, the answers to exercises, bonus exercises. We'll send it all out together to all of you guys after this third session for all the sessions. Just a heads up for those who are having trouble running the yarn command. If you want to run the tests manually, you can run them individually. So if you go to your package.json here, you can see that when you run yarn test, it just runs all of these scripts. So the only thing you need to do is append npx to each one. So npx hardhat test, price consumer test, network hardhat, npx hardhat test, that one, npx hardhat test. So you can give that a shot. I'll try and have a look at why this required parameter network is coming up. Thanks for the handy tip, Leu, I think, from the Zoom session. So yeah, one thing to note, guys, if you're getting a failure on the price feed test, make sure that you've reverted your change in the deploy price consumer contract, where we commented out the if chain ID equals 31337 part. So the issue is that it was always looking for the ETHUSD price feed from the config, and it was getting the mainnet one. So in this case, it's using the proper mock one. So if you reset that back to the original version, then your tests should all pass.
we need to uncomment that and redeploy, right?
Yes, uncomment and yeah, redeploy.
Okay, thank you.
Excuse me, can you explain more about the solidity coverage test? What does it mean?
Sure.
Thank you.
I'm just running the test again. That's better. So what it does is it looks at your tests. So in our case, we're looking at the unit tests here, these 3 unit tests, and then it's actually executing them, and then it's looking at our smart contract solidity files. So the API consumer.sol, price consumer, and random number consumer. So it's looking at all 3 of them as well.
Right.
And then it's actually working out what percentage of statements in each file was touched as part of the tests. So in the price consumer contract, 100% of the statements in that price consumer smart contract were touched or looked at in the tests. 100% of the branches, because a statement can often branch into multiple scenarios and things, were executed. 100% of the functions, 100% of the lines. But then if I go to, say, the random number consumer, only 2/3 of the statements in that smart contract were looked at in the tests. And I don't know why that's 0, because maybe I think probably there are no branches in that contract. Maybe that's why. So half of the functions. So if there's like 4 functions in the contract, then 2 out of the 4 were included in the tests. And then 2/3 of the lines. And they specifically mention line 44 and 54 as kind of coming up as not being looked at. So it just gives you a report that says how much of your contracts are you actually testing, how much of the code, because the idea is that the more code you look at in your tests, the less chance of there being bugs.
Thank you, I got it.
Sure. We'll give it 5 more minutes, guys, then we'll move on. But we're pretty much going to go straight into the final exercise. So if you haven't finished, don't fret too much. Yeah, the solidity coverage report's really awesome. I agree. It's very helpful as well. So just to reiterate on the integration test, for those who may be a little confused, So for example, the API consumer integration test does 2 tests basically, or not 2, it's kind of 1, but it tests to see that a successful request is made. And we know that a successful request is made to an API by the fact that we get a request ID, and then it waits 30 seconds for a response from the Oracle. And it also, it ensures that we get a response back from the Oracle, and we get a number, which is the volume, and that the number is greater than 0. So we're testing that we can connect to a Chainlink node and that we get a response back. All right, guys, I know some of you might be still working on that, but I'm just going to quickly go through the final exercise so that those who are up to it can kind of get a bit of an idea on what's happening. And then everyone can go back to finishing off their exercises and reaching out for help if you want. So what we're going to do in the final exercise now in the last hour is we're going to just take some of the stuff that we've learned about deploying and interacting with smart contracts in Hardhat, bit about using Chainlink APIs and price feeds, as well as tests. And we're going to create a new smart contract in your Hardhat starter kit that's going to do just a simple thing. It's going to reach out to an API. It's going to reach out to a price feed and kind of just do a basic comparison on the values and kind of store that, the result of that somewhere in the contract. And then you're going to deploy smart contract to the Kovan network, just like the other smart contracts get deployed. And then you're going to write and execute a couple tests for that deployed smart contract. And then hopefully at the end, you'll check in your Hardhat project into a public GitHub repository. So I'm not going to go through, well, because I want you guys to spend as much time, I'm not going to go through everything in huge detail because the exercise outlines it pretty well. But essentially we've got a price feed, a price exercise contract, which is very similar to the API consumer one in that it reaches out and then it kind of connects to the crypto compare API. In addition to that, it also has the code to connect to a price feed as well, because we need to do both in this case. And so you're going to create that smart contract. There's some hints to try and do it yourself, or if you need help, you can kind of highlight the text in the exercise and see the answer yourself. Then there's going to be a script to deploy that contract to the Kovan network, or to any network really, but we're going to be working on Kovan in this example. So it's going to deploy it to the network, and there is an integration test that you're going to write as well, which will basically test to ensure that you can get a value from the API and that you can get a value from the price feed. So what we're going to do now is, I might just quickly test this. So the end result should be that you should be able to deploy your contracts, including your new one, the price exercise one, to the Kovan network once we've created them. Cool. Once that's complete, you're going to run the integration tests for that smart contract, and that should execute those 2 integration tests. And we wait. And there we go. So both tests pass. So we verified that we get a value from the price feed, reaching out to the price feed, and we get a value from reaching out to the API as well. So the final step in this final exercise is to actually go to GitHub. If you haven't created an account, you'll create an account, and then we're going to create a new repository. I'll just call it something. I'm going to go create. And then you're going to go back to your VS Code, and you're going to run some Git commands. Git is the local repository manager program that you were probably hopefully installed as part of the setup instructions. And we're going to initialize the repository as a new one. We're going to add all the files. We're going to remove the remote connection to the old Chainlink Hardhat starter kit on the Chainlink GitHub. And then we're going to commit all the files to our local repository here. And then we're going to set the remote URL to our newly created GitHub URL here. And if this stuff doesn't make sense, just the exercise will kind of explain it a little bit as well. So don't fret too much. So saying we want to connect our local repository to our GitHub one there. And the final step is to say, hey, we want to push all of our code here in our local repository to our GitHub one that we're linked up to. And then we wait for that to complete. So what we've basically done is we've basically just said that, hey, we want to push all of our code here in our local repository that we've created for this Hardhat project, and we want to push it to our new repository that we just created here on our GitHub, so that we can kind of share our work with other people. So once that's done, you should literally be able to go back and just refresh your page here, and you can see your project is here, it's live, and you can kind of share it with other people. So that's kind of the final step there. So that's it, guys. I'll pass it back to you. You can continue with your exercise 2 or get started on exercise 3 if you haven't already. Reach out if you have any issues. And at 10 minutes till 2, depending on how everyone's going, we'll wrap things up and just talk about where you can find out some more information on where you can kind of learn more, and then we'll end the boot camp there. So we'll hand it back to you guys for now, and reach out if you have any help, if you need any help.
know it sounds silly, dear, but do it for me, please.
For those who have finished and are maybe doing the bonus exercises, feel free to share your links to your repo if you want in the chat so we can have a look. We'll give it another 20 or so minutes and then we'll probably start to wrap things up, and then people who are still working can continue on, and we'll hang around to help them out until 2.
I think there is a typo in the exercise. So the first exercise tells us to create a contract called price contract. And then on the deploy, it refers to it as price exercise.
Oh yeah, I see what you mean. Thanks. I'll update that.
Cool.
10 minutes.
Even 10 minutes is a long time to be away from you.
All right, guys, 10 more minutes and we're going to wrap things up. All right, a couple more minutes, guys, and we'll wrap things up. If you need help, feel free to reach out. All right, guys, how did everyone go there? I hope some of you guys were able to create the smart contract, deploy it to Coven, and kind of interact with it and run those integration tests. I received a few GitHub URLs from you guys. It was awesome to share them. Let's wrap things up now. Cool. So day 3 summary of today, we played around with local developments in Hardhat and we forked the mainnet. We talked a little bit about smart contract security, and you guys ran some unit and integration tests and kind of understood the difference between them. And then we did an exercise at the end where you guys kind of created a smart contract that uses Chainlink in a couple of different ways, and you deployed it to the COVID network. You created a test for it, and hopefully you guys checked it into GitHub as well and got some experience in doing that. So let's talk about where you can go to learn more now that you're kind of at a place where you know you can do some of these things and you want to continue to learn. So the first thing you're going to want to do is you're going to want to continue to work on your Solidity skills and to kind of grow on them. We went through some things here. However, in a 9-hour course, there's not, we can't teach everything Solidity. So there's some really cool resources out there on the net. Crypto Zombies is awesome. It's great for beginners. It will teach you a lot of concepts in Solidity. Ivan on Tech, DAP University, Eat the Blocks, and ChainShot, all great courses that you can go and kind of really build on your Solidity skills. So highly recommend those for wanting to kind of continue to learn Solidity. For using Chainlink, definitely check out our docs at docs.chain.link. We've got code examples, we've got hackathon resources, we've got all the reference data that you kind of need when you want to use Chainlink. So definitely recommend checking that out. In addition to that, we've got a really cool developers section in our blog. So at blog.chain.link, you can click on the developers tag, and we've got some, literally like our exercises, we've got step-by-step examples on building smart contracts, like creating a parametric insurance smart contract, or building your own dynamic NFT with Hardhat. There are some great guides with code repositories and step-by-step instructions on how to build those. So highly recommend checking that out as well. In addition to that, we've got Chainlink's got an awesome engineering tutorials and developer workshops playlist. So we've created some really great content on there. Patrick's a Garnet doing that stuff. He loves it. And we've got, so much good stuff there. Definitely recommend checking it out, including on guides on how to run a Chainlink node, using Brownie, using Hardhat, Truffle, and all those types of things. So one other thing I'd like to mention is if you're wanting to build something that does require the use of a Chainlink node to perform a service such as an API request or a request for randomness or any kind of off-chain computation, if you go to market.link, because you're going to want to find jobs to fulfill these requests, some of the testnet nodes or jobs on market.link may not be active or running at the time. So it always makes sense to reach out to the node operator and check with them if you don't get a response from your request, and they can kind of help you out. And in addition to that, the market.link verification is currently being reworked. So nodes or jobs of new or active operators won't always show up in search results while exploring the listed networks. 3, there are many active node operators on Discord who are willing to help you if you need something hosted or if you want a job ran. They want to gain the experience and they want to help developers realize their projects, whether it's a custom job, external adapter, or anything like that. So you can reach out to node operators in the operator request channel in the Chainlink Discord. And if you need anything sorted out in terms of a Chainlink node, they'll be able to help you out. And finally, besides using services like price fees and VRF, pretty much anything can be realized by building a customized DON or a decentralized Oracle network. So you can kind of have developers and node operators working hand in hand in a complementary manner. And developers can then have the freedom to fully focus on writing the game-changing smart contracts of tomorrow, and the node operators focus on all of the node operator services stuff and making sure everything's available. So yeah, just a summary again. Definitely check out our Discord. If you have questions, hit us up in our Discord. We've got great content in our docs, and we've got hackathon resources as well. And we are now at the end. So thank you, everyone. You've now successfully completed the Summer 2021 Smart Contract Developer Bootcamp. And whether you realize it or not, you are now smart contract developers. You have an understanding of blockchain, smart contracts. You know why smart contracts are so awesome. You've had some experience in writing and deploying smart contracts in Remix, on local environments, on the Coven environment. You know all about ETH and gas and funding contracts with Link. You've learned how awesome and easy Chainlink is to use in your smart contracts, how easy it is to connect to an API, how easy it is to get randomness, how easy it is to use price feeds. So all of that stuff. And not only that, you went into the deep end and you played around in Hardhat, which is one of the most popular developer environments at the moment, used by people like Aave, Synthetics, Uniswap. You went in the deep end there, you created smart contracts, you deployed them, you ran tests on them, you forked mainnet. All of these things are things that are done in the day of the life of a smart contract developer. And you've now done them, you've got experience with them, and you can now take that as a starting point and continue to build your skills as a smart contract developer. So congratulations again. We're going to post a feedback form. If you haven't filled it out already, please fill it out so that we can send you a certificate of completion or a POP or something. So please fill it out. I think Zach just posted it in the chat. Zach, can you put it in the YouTube as well? So with that being said, thank you for everyone for taking the time out to learn with us. Myself and the rest of the Chainlink Labs DevRel team and all the helpers and the advocates and community members as well. We had a ball doing this for you guys, and we wish you all the best in your smart contract developer journey. So thank you.
Thank you, guys. That was great.
Thank you. Great content.
Thank you, guys.
Thanks for joining, guys.
Yes, that was fantastic.
Really enjoy it. Thanks a lot.
Thank you.
Yeah, thank you, Harry. Thank you, Zach.
Of course,
Thank
man.
you.
Everyone was like super patient and fought through all their problems, and just awesome work with everyone.
It was a ball delivering it to you guys. It really was. We had a ball.
Hey guys, is the feedback form going to be sent in the email, or was a link dropped in the chat?
I dropped the link in the chat. I'll repost it here again.
I just posted it again.
Okay, cool.
Can't wait to see what you guys build next as you continue your journey now. Thanks, Sam.
Cool. Bye, Harry. Bye, Zach. Bye, everyone.
See you, everyone.
See you.